Assalamualaikum. My name is Noamira Fahana binti Razman. So today I would like to present about strategies to overcome nutrient loss in apple during the canning process. So this presentation will focus on how nutrients in apples are affected during canning and the strategies that can be used to reduce nutrient loss while maintaining food safety and quality. Canning is a widely used food preservation method that involves a thermal processing to extend a shelf life and ensure the food safety. However, during the canning process, fruit such as apples are exposed to heat, oxygen, and water, which can significantly affect their nutritional value. Apples are usually rich in vitamins, minerals, and bioactive compounds, but many of these nutrients, especially water-soluble and heat-sensitive nutrients, are vulnerable to degradation during the thermal process. Therefore, understanding on how nutrient loss occurs during canning is important to improve the nutritional quality of canned apples. Okay, so for this slide is about a problem statement. Although canning is effective in ensuring food safety and extending a shelf life, it often leads to a reduction in nutrient content, making canned apple less nutritious compared to the fresh apples. So this nutrient loss limits the health benefit of canned apple product. Therefore, there is a need to evaluate practical and cost-effective processing strategies that can minimize nutrient loss during canning without compromising safety or product quality. So, for the further research is required to identify nutrient retention strategies that balance nutritional quality, processing efficiency, and economic feasibility. Okay, for these tables, it shows the comparison between the fresh apples and canned apples. Fresh apple contain a higher levels of dietary fiber, vitamin C, and B vitamin, while a canned apple show a reduction in this nutrient. Vitamin C experienced the most significant loss due to heat and oxidation during the processing. Carbohydrate and energy content in canned apples are slightly higher, mainly due to the addition of the sugar syrup. Minerals such as potassium and calcium remain relatively stable, although the minor losses can occur due to leaching into the syrup. These are the strategies to overcome the nutrient loss. Firstly is pre-processing treatment. The first method is blanching using hot water or steam. Blanching will help the inactive enzyme such as polyphenol oxidize, which causing the browning and nutrient degradation. When it combined with acid, blanching can improve the color and stability. It also can reduce oxidative nutrient loss. Secondly is acid application such as ascorbic or citric acid. This antioxidant will reduce the oxidation and browning, helping to preserve vitamin C and phenolic compound during the processing. So these are advantages and disadvantages from the pre-processing treatment. Blanching is simple, low cost, and widely used in food industry. However, it may cause loss of heat-sensitive nutrient and leaching of water-soluble vitamin if overdone. Antioxidant pre-treatment effectively reduces oxidation and help preserve nutrients, but it cannot fully prevent heat-induced nutrient loss and may slightly affect taste if it used excessively. So the next strategies to overcome the nutrient loss is low temperature short time, or known as LTST processing. So by reducing the processing temperature and time to the minimum required for safety, thermal degradation of heat-sensitive vitamin can be minimized. Secondly, a controlled atmosphere processing, which will reduce oxygen exposure during heating and cooling. This helps prevent oxidation of vitamin C and phenolic compound. So the advantages of LTST processing will improve nutrient retention and sensory quality, and is more energy efficient than long heating process. However, improper control may risk inadequate sterilization. Next, the controlled atmosphere processing will effectively reduce oxidation and improve nutrient stability, but it requires a specialized equipment and increase the production cost. So these are the final strategies, which is it will involve an advanced technologies such as high hydrostatic pressure processing, which is also known as HHP. HHP is used as a high pressure at low temperature to inactivate a microorganism while preserving the food structure. So this method will provide an excellent retention of heat-sensitive nutrients. It also will maintain a natural color, flavor, and texture more effectively than the conventional canning. Although a high-pressure processing offers a superior nutrient retention, it also has a major limitation, which is the technology requires a high capital investment, has high operational costs, and not widely accessible to a small-scale food processor. In this slide, it compares the different strategies used to overcome the nutrient loss. So it will optimize a processing, reduce heat-induced degradation, but carries a risk of insufficient sterilization. Antioxidant addition protect against oxidation, but may affect a flavor. Reducing water contact limits nutrient leaching out, but alter traditional processing method. So overall, each strategy has its own benefits and limitation, and a selection depends on the cost scale and a desired product quality. So in conclusion, the nutrient loss in canned apple is mainly caused by heat, oxidation, and enzymatic activity, with a vitamin C being the most affected nutrient. So the various strategies such as antioxidant pretreatment, optimized thermal processing, and advanced technologies like HHP can help to reduce the nutrient loss. While advanced technologies are highly effective, there is a simpler method such as a blanching and optimized heating are more practical for small-scale producers. So, a combined approach, tailored to production needs and budget, offers the best balance between nutrient retention, cost, and practicality. That's all from me. Thank you.